I heard the old, old men say, everything alters, and one by one we drop away. They had hands like claws, and their knees were twisted like the old thorn trees. By the waters I heard the old, old men say, all that's beautiful drifts away like the waters. You're not here for poetry, are you? I bet you're here to learn how to program and to find out what I mean by breadth first. Programming is awesome. In fact, the best part about programming is you get to create wonderful solutions for challenges you may not have even known existed. Take, for example, reading. I bet you read a book like a normal person, chapter by chapter, paragraph by paragraph. Boring. Let's be a rebel and read a book in a different way. Let's read breadth first. What is breadth first? Breadth first is reading the first word of each chapter, then reading the second word of each chapter, and then the third, and so on. Here, let me demonstrate. I apologize. I can't demonstrate from memory. I have to demonstrate by reading. Take chapter. Let's what for by is example. Chapter, a breadth first. Reading. Paragraph rebel breadth first. How by and is do paragraph. Reading book, you boring. Would you like to be able to write the code to implement this? Follow me to my desk and I'll show you how. Hey, you made it. You're still here. I guess that means you want to learn how to write the breadth first code. Let me show you. Wow. Before I show you, a lot of new programmers are overwhelmed. It seems like an impossible task to start programming. And so I want to show you step by step how to accomplish programming so it's not so intimidating. What this means is we have to write a list of what we need to accomplish. And I'm going to share with you, my list of what we need to accomplish in order to write this code. Number one, we have to pick a language. And that might sound like it's obvious, but for many of you, the default is JavaScript only. And, if you watch the intro, that's actually written in JavaScript. But for this, we're going to write in GoLang. Number two, well, we need books. And I'm not expecting you to actually type out a book because that takes forever. So we need an online repository of plain text books. Me, personally, I like the Gutenberg library. Number three, we need to annotate the book chapters. I'll show you how to do that after this little segue because I don't want to, it goes a little bit long, right? Number four, we need to be able to read our book into code. And then number five, we have to be able to output that book into a plain text file. And I'm going to show you 4 and 5 iteratively along with how to use Git so we can see how the code takes place. We're going to do it one step at a time instead of all at once. You can see, why we're writing the code and how it actually functions. 6, we're going to laugh hysterically. And then 7, now I didn't put this on the list. I'm going to leave you, dear reader, with a series of challenges with the code base to improve your coding skills. And if you dare to take on the challenge, subscribe to my channel and then post your solutions in the comments below so everyone can see how you've solved the challenges. Let's get to it. Step 3 and 4 are to annotate the book into code. Before we can do that, we need to create our project. Go to the GitHub repository and clone the breadth first project to your local system. If you haven't already done so, you'll also need to install Git and Visual Studio Code. However, I would leave that as an exercise for you, the reader. The commands we're using from Git are git clone and git checkout. Git clone grabs the code from the latest version and puts it on your machine. Git checkout allows you to get a specific commit and put it on your local machine. We are going to be using git checkout a lot in this video. Browsing with Visual Studio, you'll now see the book Pele the Conqueror and the annotations to the chapter are already here. Do note, I think it was a little wonky on this video. We did 2 checkouts here. The first checkout was an empty stub project, and the second checkout was actually the version with Pele the Conqueror, the text file, and the annotations. Make sure that you have the second version so you can see the annotations in your code. How do we annotate the chapters? Well, we need to scroll through the book and find the character positions for the start of each chapter and the end of each chapter. Of course, there are many ways to do this. I merely scanned the book in Notepad++ and used the status bar to get the data I needed. You might have a better way, and if you do, share it in the comments below so we can all learn. Before we end this section, let's prove the code actually runs. To do this, we need to type go run breadthfirst.go in the Visual Studio Code PowerShell window. Does it work for you? Fantastic, it actually runs. And wait, don't go to the next section if your code doesn't run, okay? Before you go on, you want to make sure you're able to actually run the code and see hello world. If that doesn't work, debug and troubleshoot until it works, and you'll get much more value from the next sections. Now for our first section of code. All we're going to do is load a file into memory using a file stream, check for errors loading that file into memory, release that file, and then exit. Very simple. We're not going to do anything complicated. We're just going to try to understand these several lines of code to see why each line works and why we're doing each line. The very first line, you'll notice we have file stream, comma, common error equals, and we're opening the file stream. What this is doing is it's taking some file from your system, opening it as a file stream or a reference, and then placing it in these variables. The very next line, called check for error and fail, we're saying, hey, well, did we fail to open that file stream? And if so, bail out. And with Go, this is the common pattern on how we exit when there's a catastrophic error. I'm not a big fan. I like more robust error handling, but this seems to be the way Go programmers like it. If you have a better method, well, put it in the comments below so we can all share from your knowledge. The final line of code in this section is to release the file stream. Now you might ask yourself, well, why bother because the code's exiting? If you're new to programming, you may have never experienced this error. With some programming languages, if you don't close your file stream, you can get errors where the files are actually locked, and you can't edit or delete your files until you reset your operating system. It's a very annoying error to have, and so be good stewards of your code and clean up resources when you're no longer using them. Now that we have this code complete and you kind of understand what we've done, what I want you to do is take the first line of code and change the file name to another file name on your operating system and try and open in another file. Now, don't be lazy. Actually run it and see if it compiles and see if any errors happen. And then go on to the next section once you're confident in what this code does. Let's do some actual logic. We're now going to read in our CSV file and print out each line just to prove that we can. By printing out now, we know that we're able to accurately, confidently read in the CSV file. After checking out this specific version, let's examine the imports and see what we'll need. And I apologize, I forgot to show you the imports for the last section, so you probably had to find that out on your own. And, just a personal note, I hate it when tutorials skip the imports and you have to look everywhere just to find out where these esoteric libraries are hidden. So I apologize, I'll try to show this more in the future. The imports we have are encoding/CSV. This import allows us to read in line by line our CSV file. Next, we have format import. This allows us to do, interesting things like printing out to the console. You'll see that. OS gives us access to operating specific methods, specifically os.open for our file stream. That's the one I forgot. And then last, we have strconv, which I like to say string conversion or string conversion. This gives us methods to do things with strings that we might find interesting, like perhaps changing text into an integer. The first new line of code we have is on line 28. We're going to create a CSV reader so we can read in the CSV file. A CSV reader knows how to take a CSV file and read it line by line and tokenize the lines so that we don't have to. Basically, it splits the columns for us to make our lives a little bit easier. Now, if you want to challenge, what you can do, write your own function to create your own CSV reader and tokenizer, and then replace line 28 with your code and see if it works, and then understand why we use the import instead of doing it on our own. Line 33 is a for loop and an enumerator or an iterator depending on your language. The section of code in the statement block that follows the for loop will be executed for every single line in the CSV file, or more generically, for every single instance in your iterator, the statement block will be executed. On line 33, we're going to check and see if we're on the first line of the CSV file. Notice the index here, it starts at 0. And this is kind of important when you're learning new programming languages, because some programming languages start at 0 for indexes, some start at 1, and some programming languages actually allow you to have custom start and end indexes, which can be absolutely crazy. The purpose of the code on line 33 is just to skip that first header line. And if you don't skip the first header line, you know what? The code's going to crash. In fact, if you want to have some fun, comment out lines 34, 37, and 48, and then run this code. And what you're going to see is you're actually going to get an error when we try to process the lines in a CSV file. Line 38 and 41 attempt to turn the string values into integers. And if the value can't be converted into an integer, it will say in the common error that, hey, record 0 or record 1 cannot be converted to an integer. And so you don't have to look it up, because I know many of you that are watching aren't familiar with programming. An integer is a whole number or a counting number. You know, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 1000, negative 1, negative 100, negative 200. Usually when we're using indexes, we only use 0 and positive numbers. Also, we have the concept, and we're not using it here, of floating point numbers or double precision numbers. Pi 3.14, that's a floating point number. So any number with a decimal is a floating point number. Interesting fact, an integer is also a floating point number, at least in programming, because you can stick it in that box and it works. Another interesting note on lines 38 and 41 about parseInt is in GoLang we have to provide the base and the number of bits. And so here we're using base 10 numbers for 64 bits. Finally, line 47 is the money shot. We're actually going to show the results of our code on screen and prove that it actually works. If you're a good programmer, not me, you'd probably write unit test here instead of printing out. Good programming practices would use unit test instead of print lines. And one of the challenges that we're going to have at the end of this video, I'm going to ask you, viewer, to write unit test on this code. So here's a hint. When you see print lines, so we can visually verify code works, that's a hint that, hey, we probably should have written a unit test. As promised, here are the imports for this version of the code. Notice that the format has actually disappeared. One of the cool features of GoLang is when you update your code and a reference is no longer needed, it will automatically remove the import when you compile the software. This can be great for production code. However, it can be a little bit annoying when you're actively developing code and have to keep going and adding imports again because they keep flying out as you adjust your comments. Do you want a challenge? There's actually a method in GoLang where you can adjust your imports so they will not disappear when you remove the reference in code. Take your break, go take a look and see if you can find out. And if you do discover it, drop it in the comments below and share the knowledge with everyone. GoLang doesn't have tuples. This means we need to create a struct to hold the chapter information from the previous version. Line 9 through 14 is the syntax of struct in GoLang. On line 12 and line 13, we create two variables to hold the starting and the ending index of each chapter reference in our chapter CSV files. Remember, the chapter CSVs are the annotations containing when the chapters start and when the chapters end. Not mentioned in this code is that starting indexes generally are inclusive and ending indexes are generally exclusive. In the diagram I'm showing right now, notice how greater than or equal to 6 includes the value 6, and less than 3 excludes the value 3. Keep this in mind as you learn to program, as there are subtle errors that can crop up in programming. For example, check out the between statement in SQL. As an exercise, try and discover a common problem that can occur using the between syntax in SQL statements. Line 17 through line 22 is the GoLang method to create an instance of struct. Notice the naming convention. The function is named new, and then the name of our struct, in this case, new chapter. And the return result is a pointer to a chapter struct. Line 18 allocates memory for our struct, and line 19 and line 20 assigns the appropriate values to the struct. Finally, line 21 returns the reference to our newly created struct. Line 36 illustrates how we intend to use our struct. We're going to use our struct as an array of chapters, and this will give us a convenient variable that contain all of the chapter information from our CSV file. Line 64 illustrates how we create a new chapter with our start and end index. Line 65 appends a new chapter to the end of our array using the built-in helper method in GoLang. While beginners are not often concerned with performance of append, it's important to understand that if the current array doesn't have space, GoLang will allocate a new array and then copy the existing array to the new array and then do the append. This can actually slow things down. If you're going to be appending a lot in GoLang, you might want to look into creating your array and already allocating the number of spaces you're going to need. Or you can look into other more advanced data structures. Advanced data structures are out of scope for this video. However, you can look into linked list, doubly linked list, queues. My mind is blanking right now. What comes after a queue? Oh, a stack! Or other associated data structures. In fact, it makes for really great reading. If you're learning to program and you don't know much about data structures, take a look at some of the data structures and just know, when you take a university course in computer programming, the very first university course, you learn a little bit about syntax, and then you spend a lot of time actually manually developing these basic data structures so you can understand when to use them and how they affect performance. So I highly recommend implementing these data structures on your own and doing some of this research, even though we all know you're going to say, it's already done for me, so we don't have to. Well, that's on you. If you really want to learn, though, look at the data structures. It's going to help. Next, we're going to read in the actual book from the text file and print this out to the screen. To do this, we'll re-add the format import statement. Check out line 73. What we're doing on line 73 is creating a buffer or a byte array with all the data for the text file. The code is about to get very interesting, so play back this section a few times until you get what we're doing. On line 76, we're scanning our chapter's variable, creating a loop that we can iterate over for each chapter, and we can place that into a local variable record for each chapter. Then on line 78, we're going to use this information and slice it into our buffer. A slice is like a window into an array. Remember when we discussed the importance of inclusive and exclusive? Here on line 78, you can see that importance coming into effect. On line 79, we're then going to convert our slice into a string variable and place this data into a new local variable called chapter. Now, we're actually going to change this later, but it's called chapter now. This variable contains the proper text for the chapter. To prove this, we're going to use line 81 and print out the first 100 characters to the console, and we can manually verify. Again, if you want a great exercise, write unit tests so we can automatically verify that this code works. For now, just type go run breadth first go and hit enter and see if your output matches mine. Next step, check out the version listed on your screen below, or below, I don't know where I'm putting it, and we're almost finished. Once you've checked out the code, we're going to add a tokenizer. A tokenizer is a tool that automatically breaks up text into tokens. Tokenizers can use spaces, tabs, commas, or any other system to create tokens. New developers often write their own tokenizers, but just be warned, this is a solved problem. So there's not really a reason to write your own or roll your own. Just use a library in the language of your choice. The import that we're going to use for this is buff.io, which has scanner and GoLang, and the scanner, of course, is our tokenizer. We will then use the strings import for the string reader capability. Line 85 creates our string reader, and line 86 creates a scanner for that string reader. It isn't terribly important to understand the string reader. String readers are an abstraction for reading strings using a generic reader that can read one character or byte at a time. Line 86 demonstrates how to create a new scanner variable from the string reader, and line 88 is very important. In fact, it took me a little while to find this. We have to change our scanner from defaulting by lines to defaulting by words. Most scanners, or the ones I'm familiar with, default to words, so I wasn't prepared to look for this. You might have to see this. This might come up in your own programming, where you have to change default behavior of the tools that you use. Line 89 will then append the scanner for this chapter into our scanners array. We'll need the scanners array to read the book in just a little bit, or actually in this next bit. So check out this version that's on the screen below. This version is going to take us almost there. We're not even going to need any new imports. On line 100, we have an important concept in programming. So I'm going to step back a little bit. Strings are immutable. This means once you create a string in memory, you can't change that string in memory. Instead, the system will create a new place in memory and copy over your new string. This requires an allocation for every time you do a string operation. And it can be inefficient. And string operations like concatenation, or when you want to take out a substring, it creates new strings all the time. This is where string builders come into play. A string builder allocates just a base amount of memory and does all the operations in memory without new allocations. And then when you're finished, you can convert that string builder into your own string. This eliminates a lot of additional allocations, and it's good programming practice. Now, this is a fine line. Creating a string builder has some overhead. So if you're just concatenating one or two things, don't worry about a string builder. but know that string builders exist, and this is why you use string builder. Line 105 and line 106, we iterate through each of our scanners. On line 106, we return true if scan has a token, and then we set token found true in line 107. Then on line 108, we actually read that token from the scanner into a variable. And on line 109, we're getting a bit fancy. We need spaces between our words, but we don't need a space for the first word. So what we do is we check the string builder variable. And if the string builder is empty, well, we don't need a space because there hasn't been any words. But if the string builder is not empty, then we add a space. And this little hack I use all the time with string builders so we can have commas or spaces in the right place. Line 113 is where we append the word to our string builder. Okay, technically, we're complete. And technically correct is the best kind of correct. However, check out this version of the code and we're going to have new lines to our wall of text. The new lines will make the wall of text a lot easier to read, and if you didn't know this, some text editors will actually crash if you don't have any new lines, so we're going to prevent crashes for people that want to read this text. To do this, we add a character count variable on line 103, and on line 111, we update the character count with each word. Then on lines 119 through 123, we'll append a new line special character to the string builder when at least 80 characters have been passed. We don't care if it's exactly 80 characters, so this is good enough code. And if you're new to programming, you might be curious why we have a backslash on line 122. The backslash is an escape character, and that tells the system that we have a special character. So it's a backslash, then that special character, and the system will do it. Well, what do you need if you want backslash? Well, backslash, backslash. And then you write 2 backslashes to actually do 1 backslash. We're almost done. Check out this specific version, and we're going to demonstrate how to output our great work to a text file so that we can read it for our own amusement. Line 31, we create an output file, stream titled output.txt. It doesn't really matter. A lot of programming is actually centered around writing to streams, so get used to this type of code. Because we already have all the text written, we can write all the text in one go on line 134. If you want an exercise, it's kind of good practice to not have these monolithic blocks of memory in code. What we should really do is use streams throughout our entire code, and this means we don't need a lot of memory, but it can be a little complicated. So if you want a really challenging exercise, go through this code base, and instead of having this giant chapter or this giant book in memory, change that to actually be a stream, and then write to the stream as we're processing the code. And then we'll actually use a lot less memory. But that's an advanced example. In fact, it's not even, I don't think it's on the examples. I don't think it's on the exercises that we have at the end. So if you want to do that, it's an advanced challenge, but try it. It can be fun. Line 135 syncs the output stream. This is important because the OS may not have actually written data to the stream yet. Some programming languages will actually let you close a stream without writing any data, and you'll get like half-written files, and it's so confusing. Like, well, where's this error? And it's because you didn't sync or you didn't flush. It depends on your API, which you have to call. Finally, and of course, since we're good stewards, we close the output stream on line 136, and we prepare to read our masterpiece. In PowerShell, type run, breadth first go, and hit enter, and then open the output text file, and let's see our masterpiece. It's stone there at Pele Pele Christmas. After a come Pele in she f oh it the out Pele grandmother. Oh, they was, farm was, for was, had Eve, what was all safe, cubby was, Pele's must. Why can't we read all books like this? Not perfect, but it's completely hysterical. Why can't we read all of our books like this? I'm glad you made it this far, dear viewer. And before I leave you with the final exercises, can you do me a massive, solid favor? Click subscribe, leave a comment, and click like. Not only does it feed the algorithm, it boosts my ego, and we can all use a little ego boost, right? All right, here are the final exercises. Complete these exercises on your own, and it'll help you on your way to becoming a great programmer. Number 1, refactor breadth first go to have multiple methods that adhere to solid or dry principles. Number 2, add appropriate unit tests to test your new methods and all the methods in this code. Number 3, add the ability to read in the book from command line arguments. Number 4, add acceptance tests to complete functionality. And finally, number 5, the optional challenge integrate with a third-party API library to automatically read the book when we're finished. Happy coding!
Nästa gång vi ses så kanske du får ett redigt hem och komma till Pelle.
Hils Karne mange gange. Farvel og tak.